Hello everybody. In this video we're going to practice normal distribution. We're going to set up our own accurate Excel spreadsheet calculator, and we're going to set up our Wolfram Alpha definite calculator. We're going to learn how to read z-scores, and we're going to practice lots of problems. Let's begin. Normal distribution has two parameters, mu, sigma squared. Here, mu is the mean, average or expectation, and sigma is the standard deviation. And sigma squared is the variance. If normal distribution has the parameter 0, 1, which is expectation is 0 and standard deviation is 1, it is called standard normal distribution. So if it is standard normal distribution, then the expectation is 0 as the first parameter here. So that means probability that x is less than or equal to 0 is 50%, because 50% of the entire region is to the left of the mu. Probability that x is greater than some value a means 1 minus probability that x is less than or equal to that a value. For example, if we are calculating probability that x is greater than 1 in this standard normal distribution, so we're calculating this region. Entire region is 1, so 1 minus this region will give us probability that x is greater than 1, which we can rewrite as 1 minus probability that x is less than 1. If probability is between two values, like probability is between a and b, such that values, that is by definition probability that x is less than b minus probability that x is less than a. We can also express this in integral. So probability that x is between a and b means integral from a to b of the density function of normal distribution, which is e to the negative x minus mu, the quantity squared, over 2 sigma squared all over sigma times square root of 2 pi dx. So this integral will give us the region between a and b. You can also use integral for x is greater than 1 or x is less than some value. So this time the other limits of integration will be either positive infinity or negative infinity. Let's begin the questions and see how we are using it. Just before we start the problems, we're going to make our own Excel spreadsheet calculators. Our first calculator is the standard normal distribution calculator. Our parameters are mu is 0 and sigma is 1. And x1 is the value that we are computing. x2 is the second value we're computing. And if we're looking the area between x1 and x2, then this green area will give us the answer. So our function will be like this. Let's say we are computing x is less than 2 and x2 is less than 3. So here we are computing x is between 2 and 3. Here the function we're going to write is equal sign, and click letter N on the keyboard, and automatically the ready functions will come out. So you're going to click on norm.s.dist, double click, and we have two parameters here. The first parameter will be the x value we are computing, comma, the second parameter will be true, close parenthesis, enter. and true is cumulatively adding. So this is the probability that x is less than 2, which is 97.72%. And this is one of the most accurate calculator. And if you need more digits, you can expand it. So what is the probability that x is greater than 2? So that is the complement of the probability of 97. So the function we're going to write here is equal sign 1 minus this probability here, enter. So this is the complement. So if you need x is greater than 2, then you're going to use 0.02%. If you're needing x is less than 2, then you're going to use 97.72%. So what is the probability that x is less than 3? We're going to write another function here. So equal sign, similarly, normal as distribution, double click, and first parameter is the x value we're computing, comma, true, which is cumulatively adding, close parenthesis, enter. So that is 99.86%. And we're going to write here complement, which is equal sign 1 minus this cell, enter. And the region between 2 and 3 will be equal sign this probability minus that probability, enter. So that is going to be automatically coming out here. Now our calculator is ready. Let's test it out. Probability that x is less than 1 is automatically this. Probability that x is less than 2.1 is automatically this. Probability that x is less than negative 1.2 is automatically this. And in between is this. Now, what if our distribution is not normal distribution? Then we have to find the z-score. We have to standardize it. And we need to convert it like mu is 0, sigma is 1. So for that, we're going to compute the z-score. And that formula is x minus mu divided by sigma. So let's write z-score formula here. Equal sign, parenthesis. That is going to be the x value we're computing minus mu value we are going to write here soon, close parenthesis, divided by sigma standard deviation value we're going to soon write here, enter. Now, since we did not write any numbers here, nothing came out. Let's write our mu is 100, our sigma is 20, and let's say our x value we're going to compute is, let's say, 110. So our z-score is 0.5, automatically came out, because the function we have written here executed x minus mu divided by standard deviation. Let's write our z-score for x2 as well. We're going to write the same function, equal to, open parenthesis, x2 value minus our original mu value, close parenthesis, divided by sigma, enter. And let's say our x2 value is 120. So automatically our z-score is 1. Now let's write out our normal distribution function based on the z-score. So probability that x1 is less than x is equal to normal distribution, double click. Our first parameter will be our z-score here we're computing, comma, true, which is cumulatively adding, enter. So it is 69.14%. And x is greater than x is the complement of 69%, which is equal sign 1 minus that probability, enter. We're going to repeat exact same functions for x2 values. Equal sign, normal distribution. The first parameter we're going to plug in here is the z2 score, comma, true, which is cumulatively adding, close parenthesis, enter. And this part will be the complement, equal sign 1 minus the probability above, enter. And the area in between is automatically written here, but let's write it again, equal sign x2 probability minus x1 probability here, enter. Our normal distribution calculator is also ready, so that will automatically standardize, calculate the z-score, and compute out the probability for us. Let's test it out. What is the probability that x is less than 105.78? It automatically gives us. What is the probability that x is less than 111? So this. What is the probability in between 105.8 and 111 is this probability. So our second calculator is also working. Now let's work out on inverse normal distribution. Inverse normal distribution is the inverse function of the PDF of normal distribution. So the probability is given, then what is the z-score? So what we're going to write here is the probability actually. So let me change it. So phi inverse is the z-score of that probability, corresponding probability. If you know the probability, let's say probability is a number between 0 and 1. So let's enter 0.256847. So the inverse function we're going to write here will be equal sign. We're going to click on n, and then this time norm.s.inverse. Double click. And this time we have one parameter, just that probability. And close parenthesis, enter. So that is the corresponding z-score of that probability. What if it is not in the standard form? It is not standard normal distribution and we don't know that. So first we need to standardize it. So let's say our mu is 100, our standard deviation is 20. Let's say our x value is 110. So here our z-score actually will be equal to parenthesis x minus mu close parenthesis divided by sigma. So we obtain 0.5. So z of 0.5 will give us the f inverse. Let's write same function here, equal to n normal as inverse one parameter, which is this value here, close parenthesis, enter. And that is working correct because probability of being 50% is 0. What if it is 120? Then it is 1, and 1 is the upper end, so it didn't give any value because it goes up to 99.999. So let's use here 119. Okay, so that z value is 1.64. So our inverse normal distribution calculator is also working. Our calculator is ready. Now let's set up definite integral and then start the problems. So just before we're setting the definite integral on wolfram alpha, we're going to set it manually by hand to understand the logic of it. So probability that the x value is between a and b means integral from a to b of the density function, which is e to the negative x minus mu, the quantity squared, divided by 2 sigma squared, all over sigma times square root of 2 pi dx. And probability that x is less than a means integral from negative infinity up to the value of a, the same density function. And probability that x is greater than a means integral from a to infinity of the same density function. Let's say our normal distribution has the parameters, let's say 100, 20 squared. So here that means our mu expectation is 100 and our standard deviation sigma is 20. So in this case, in this function, our mu here will be 100 and our sigma here will be substituted with number 20. Now let's do it on wolfram alpha. If you type wolfram alpha definite integral calculator on your search engine, you can come across with this website. And the integral function you're going to write is e exponent, which is shift 6, negative sign. Now we need double parentheses, so I use curvy bracket and normal parentheses. You can use double parentheses if you want, and it's going to be x minus mu. Let's write mu for now. Close parentheses, and again exponent squared and divided by open parentheses 2 times sigma squared, close parentheses and close the curly parentheses or bracket, and everything divided by sigma times square root, and between sigma and square root, if you want, you can write times sigma times square root of 2 pi pi, close parentheses. So our function is ready. Let's say you're computing x from 100 to 120, and let's say your expectation is, your mu is, let's say 105, and let's say your sigma is, let's say 20. So you have to change sigma here 20 and then submit. So this is the integral value, 0.372079, which is 37.2%. Let's say in this integral you would like to know the value that x is less than 110. So from negative infinity to 110. So that is 59.87%. So what is the probability that x is greater than 120? So x is from 120 up to infinity. So that's 22.6%. Okay, we have all necessary tools. Now we can start solving the problems. Problem number 1. Given that z is a standard normal random variable, probability that z is between -1 and 1.5 is equal to. For this, our Excel calculator VSET can solve it. So x is between -1 to 1.5 is equal to 0.7745, which is 0.7745. Part B is asking, given that z is a standard normal random variable, p of z is less than or equal to z is equal to 0.2580 is what? So this time we were given probability. So what is the corresponding z-score for this probability? So we're going to use inverse function. Phi inverse of this probability is equal to that z. Because if we take phi inverse of this and phi inverse of this, that comes out as z, and this will come out as the calculator will tell us. This time we're going to use inverse normal distribution, and the value we're going to plug in is 0.2580. So 0.2580, enter. So it is negative 0.6495. Problem number 2. Which of the following is always true for all probability density functions of continuous random variables? They are symmetrical. They are not all symmetrical. Each continuous random variable has their own unique shape. They are bell-shaped. Normal distribution is bell-shaped, but not all of them. They have the same height. Not all has the same height. The area under the curve is 1. That is true because the area under the curve is the entire probability, and the entire probability is 1. So this is true. Part B, like the normal distribution, the exponential density function. So before we comment on the choices, let's draw the normal distribution and exponential distribution. The normal distribution has a bell curve shape, and exponential distribution has some decaying function shape. So what is common between is, as x is approaching to infinity, the value of the function is approaching to 0. So D is correct. They are not both symmetrical. F of x approaches the infinity as x approaches the 0. It is quite the opposite. Bell-shaped, only this is bell-shaped. So the common is, so the density function is approaching to 0 as x is approaching to infinity. Problem number 3. Suppose that x is normally distributed with mean 110 and standard deviation 15. What is the probability that x is greater than 135.5? Probability that x is greater than 135.5 means 1 minus probability of x is less than 135.5. And our normal distribution has the parameter 110, 15 squared. Here 110 is our mu, and 15 is our standard deviation sigma. Since we set our calculator already, we don't need to compute x is less than 135 and subtract this from 1. We can directly plug in our calculator. X is greater than 135.5. So let's go to our Excel calculator again and click here. This time we have to write our parameters. Mu is 110 and our sigma is 15. Our z-score will be automatically calculated here when we enter x1 value, which is 135.5. So our z-score is automatically 1.7, and our probability that x is greater than x is 0.0445. So the probability here is 0.0445 because it is x is greater than 135.5 is the complement of x is less than 135.5. Part B is asking what value of x does only the top 19% exceed. So that means that is z of x minus mu over sigma is equal to top 19% means 1 minus 19%. So we have to be careful about here the vocabulary. Top 19 is the 1 minus 0.19. If we compute this, 1 minus 0.19 will be equal to 0.81, and here we have z of x minus mu over sigma is equal to that value. And if we take inverse operation, inverse phi inverse of this value and phi inverse of that value. This value comes out as whatever is inside of the parenthesis, x minus mu over sigma is equal to phi of 0.81. Our calculator can handle it. 0.81 is 0.8778. 0.8778. Let's use one more digit. 96. Let's use two more digits. And here we know mu and sigma. Our mu is 110, so we can substitute this. And our sigma is 15, we can substitute this. Now we're going to solve for x. So first we're going to cross multiply. So x minus 110 is equal to 15 times 0.877896. And then we're going to add 110 on both sides. So x is equal to 15 times 0.877896 plus 110. And if you plug in those numbers in your regular calculator, you're going to obtain 123.17. Problem number 4. Suppose the scores of students on a statistics course are normally distributed with mean of 371 and standard deviation of 74. So our normal is 371, 74 squared. What percentage of the students scored between 371 and 519 on the exam? That means that's the probability that x is between those two values. Since we have parameters here, mu and standard deviation, so we can directly plug in our calculator. But let me write manually what that means. That means probability that x is less than 519 minus probability that x is less than 371. And we need to standardize that. We can standardize it like z-score is equal to x minus mu over sigma. So here 519 is our x value. So 519 minus our mu, which is 371, divided by 74. That's the probability of this z-score. You can check z-score table or you can plug in direct the calculator. And this is the probability of x is 371 minus 371 divided by 74. So this value is p of 0. And we know that p of 0 is 50% because now we standardize it. So in the bell curve, 0 is the 50% of the entire region. So that is 0.5. So you don't even need to use calculator for this part. For this, it's going to be 519 minus 371 divided by 74. Whatever value you get here can be checked on the z-score table, or you can use directly the calculator. Let's use our calculator. 371 is the mu and 74 is the standard deviation, and we want to know the value between 371 and 519, so it is 47.72%. So our answer is 47.72%. Problem number 5. Find the following probabilities for the standard normal random variable z. So our normal is standard with parameters 0, 1. So we can directly use z-score table. Or we can directly plug in our calculator we set up on Excel, and then we can execute the value directly. But for the sake of practice and reading the z-score table, let's solve part A and part B using the z-score table. In part A, it's asking the probability that z is between negative 0.61 and 1.37. That means probability that z is less than 1.37 minus probability that z is less than negative 0.61. And if we go to our z-score table, first let's write down our probability that z is less than 1.37 minus probability that z is less than negative 0.61. So we need to find this value. First we go to positive 1.3. We found 1.3 here, and then we go to 0.07 here. So that is the probability of 1.37. So 91/46. And probability that z is less than 0.61 negative, so we go to negative 0.6 on this column. Let's use different color. So negative 0.6 is here because 0.0, 0.1, 0.2 going through 0.9. So the probability that z is less than negative 0.61 is 27,093. And if you do this subtraction, you're going to obtain 0.6437. So that's the answer for the part A. So for part B, we're going to find the z-scores of negative 2.14 and 1.48. So negative 2.14, so we go to negative 2.1, negative 2.1, and 0.04 digit here. So we intersect this 0.04 and negative 2.1, which means negative 2.14. And 1.48, so we go to 1.4. So 1.4 is here, and 0.08 is here. Now we know how to use z-score table. Let's directly use our calculator. So we're going to go to our standard normal distribution and find the area between negative 2.14 and 1.48. So that is 91/43/8. So what is the probability that z is less than 1.13? So calculator will tell directly. If we enter here 1.13 and less than, it is 87,076. And what is the probability that z is greater than negative 0.98? Greater than, so it is 83,645. Problem number 6. Find the value of the standard normal random variable z called z0 such that part A is asking probability that z is less than or equal to z0 is given this probability. So since we were given this probability, we're going to find the corresponding z0 value. For this, we're going to take inverse operation. So phi inverse of probability that z is less than or equal to z0 is equal to phi inverse of 0.8006. This goes out as z0, and phi inverse of that value, we can use the calculator directly. 0.8006 will give us 0.8437. And you can use more digits if you wish. Part B is asking probability that z is between negative z naught and z is this probability. So we're going to find the value of z naught. We were given symmetrically, this is standard normal, so negative z naught to z naught is equally away from the mu. So let's say this is negative z naught and this is positive z naught, and we are equally away, and symmetrically this area is equal to that area to the right. So we can express this probability as 2 times probability of z is less than z naught minus probability that z is less than 0, because this is mu, which is equal to 0. So we take the area from 0 to z naught. This is white area here, and we multiply it by 2. We double the area because of the symmetry, and that is equal to this given probability. Now we know that probability z is less than or equal to 0 is the 50%. So this property is useful. Now we can distribute 2 inside of the parentheses. So we're going to obtain 2 times probability of z is less than or equal to z naught minus 2 times 0.5 is 1 equals to this probability given. Now we can add 1 on both sides and divide by 2. So we obtain, let me clean here and continue writing here. So probability that z is less than or equal to z naught is equal to 0.2298 plus 1 divided by 2, because we add 1 on both sides and divide by 2 to isolate this. Now this value is equal to 0.6149. Now we take phi inverse of both sides. If we take phi inverse of this side, z naught goes out, and if we take z inverse of this, we're going to use the calculator, inverse normal distribution calculator. So that is 0.6149 is equal to 0.2921. So 0.292113, and if you want you can go more digits, the calculator has it. Now let's go to part C. Part C has exact same logic as B, so probability of this is equal to probability that z is less than or equal to z naught minus probability that z is less than or equal to negative z naught equals to that probability. And we're using the symmetry again, negative z naught to positive z naught. So we're calculating from 0 to z naught because that's what we're solving for. So we take this region and we double it, so we multiply it by 2. So 2 times probability z is less than or equal to z naught minus probability of z is less than or equal to 0 is equal to given probability 0.2854. And we know that this probability is 0.5 by the property of standard normal. And if we distribute 2 inside of the parentheses, we get 2 times probability z is less than or equal to z naught minus 1 is equal to 0.2854. And we need to isolate this term. So probability of z is less than or equal to z naught is equal to 0.2854 plus 1 divided by 2. And this value is 0.6427. And now we take the inverse of both sides. And phi inverse of this is z naught. And phi inverse of the right term is 0.6427 is equal to 0.3656. And again, you can take more digits if you wish. Part D is asking probability that z is greater than or equal to z naught is this probability. So let's rewrite it first. We know that this probability is equal to 1 minus p is z is less than or equal to z naught, because we need to take the complement. And we need to isolate this term. Now we're going to subtract 1 on both sides. So negative p z less than or equal to z naught is equal to this value minus 1 is negative 0.7727. Now we're going to multiply both sides by negative sign. And next step, we're going to take the inverse, phi inverse of both sides. Phi inverse of left hand side is z naught. Phi inverse of the right hand side, the calculator will tell us it's going to be 0.7727 is 0.74776. So the calculator will tell you directly. Part E is asking z value between 0 and negative z naught. So that is, by definition, probability that z is less than or equal to 0 minus probability that z is less than or equal to negative z naught is equal to given probability. We know that this is equal to 50% because that is standard normal, minus p z less than or equal to z naught is equal to this probability. Now we're going to subtract 0.5 on both sides. So we're going to have on left hand side probability that z is less than or equal to z naught is equal to this value minus 0.5 will give us negative 0.0279. Now we're going to multiply both sides by negative sign. So probability that z is less than or equal to negative z naught is equal to positive 0.0279. Now we're going to take the phi inverse of both sides. Phi inverse of the left hand side is this value, negative z naught. And phi inverse of the right hand side is 0.0279 is negative 1.91259. But this is negative z naught value. We need positive z naught value, so we multiply by negative. So 1.91259. Part E is asking this probability. So this probability by definition is equal to probability that z is less than or equal to z naught minus probability that z is less than or equal to negative 2.27 is equal to given probability, which is 0.5368, negative 2.27. So we go here, type negative 2.27, and the area under 2.27, negative 2.27 is 0.011603. Now we can add this value on both sides. So probability that z is less than or equal to z naught is equal to sum of these two values, which is 0.55283. Now we can take phi inverse of both sides. So phi inverse of left hand side is Z0, and phi inverse of right hand side, again the calculator will tell us 0.55283 is given as 0.132814. So this is the answer. In these type of questions, the important thing is to know probability of z is less than or equal to 0 is equal to 50%, and the definition of the interval, and all the rest is done by calculator. Problem number 7. Consider a normal distribution curve where 75th percentile is at 19 and 10th percentile is at 9. Use this information to find the mean mu and the standard deviation sigma of the distribution. 75th percentile at 19 means probability that x is less than or equal to 19 is equal to 75%, which is 0.75. And simultaneously, probability that x is less than or equal to 9 is equal to 10, because that is what it means to say 10th percentile is at 9. Now we are going to standardize this x is less than or equal to 19 and x is less than or equal to 9. So we're going to use z standardization for that, which is x minus mu over sigma. In our case, our x is 19, so 19 minus mu over sigma is equal to 0.75, and we're going to apply simultaneously the same operation here. So in our case here, our x is 9 minus mu over sigma is equal to 0.10. Now we're going to take inverse operation of the both sides. So phi inverse of left hand side and phi inverse of right hand side. Simultaneously phi inverse of left and phi inverse of right hand side. Here on the left we obtain 19 minus mu over sigma, and here on the left we obtain 9 minus mu over sigma. On the right hand side we have to take phi inverse of 0.75 and phi inverse of 0.10. For this we're going to go to our calculator and we're going to use inverse normal distribution. So 0.75, this is the number we obtain, and 0.10, this is the number we obtain. Now we can go ahead and copy this. So 0.75 is equal to 0.6744897501, and if you wish you can copy more digits. And phi inverse of 0.10 was negative 1.28, 15, 51, 56, 54, 55. We can leave it here at this digit. Now we're going to solve for mu and sigma. So we can cross multiply and then create systems of two equations. So 19 minus mu is equal to 0.67 number times sigma. Let's write sigma in different color. So all we did here was to cross multiply. We are doing just algebra here. And similarly, we are going to apply it for the second equation here. 9 minus mu is equal to now we have two equations and we can apply systems of equations. So we're going to subtract the second equation from the first equation, and if we multiply everything by negative sign, this becomes negative, positive, positive. And 19 minus 9 is 10, mu's cancel out, and this is going to be addition of two sigma values, and if we add them up we obtain this number. And sigma. Now we can solve for sigma. So sigma is equal to 10 divided by the coefficient of sigma. So that's going to be that 1.95 number. So these cancel out. So sigma is equal to 10 divided by 1.95 number. So our sigma is equal to 5.11 2366. And you can stop at any digit you prefer. So now we know the value of sigma. Now we can place sigma in one of the equations and solve for mu. Let's place sigma in any equation you prefer. Let's put it here. So in that case we are going to have 19 minus mu is equal to 0.67 number, and instead of sigma we have 5.11 2366. So mu is equal to this number times that number, minus 19, because we subtract 19 on both sides, and we multiply everything by negative sign because we want positive mu. And in this case mu is obtained as 15.5517. So our mu is this. So all we did here was to create two equations and solve the systems of equations in this problem. And initially we interpreted 75th percentile and 10th percentile in probability. Problem number 8. Let x be normally distributed with mean mu and standard deviation that sigma is equal to mu. Also suppose probability -5 is less than x, that is less than 12, is equal to 58.35%. Find the value of the mean mu. So for this question we have two different approaches. Either we can integrate the density function of normal distribution from -5 to 12 and set it equal to 58.35% and find the mu and sigma. But this is not gonna be easy because the antiderivative of this PDF function will be error function, which is Gaussian normalization. So it is not very easy to get very correct accuracy this method. Or you can continue doing standardization, but this time again the answer is deviating two integers. Instead of these two approaches we're gonna go to trivial solution, which is trial error calculator solution. But we're gonna do clever guess, and our start point will be very close to our trial. We know that our bell curve is from -5 to 12. B minus A divided by 2, which is 12 minus -5, divided by 2 is 17 divided by 2, which is 8.5. So we know that our answer is close to this 8.5. So mu is around 8.5. So we're going to go to calculator and we're going to write the area from -5 to 12, and we're going to give same value for mu and sigma, and we knew it 8.5 is our start point. Either we will go some decimal points below or up. So the area is here now 60%, 60.36. So that means we need to increase mu a little bit. So 8.6. Then sigma has to be 8.6. Then the area became 59.68%. We need to continue until we find 58.35%. And it is 59.01%. 8.8 is bingo, 58.35%. So at 3 trial you can find the answer. 3 jumps will find the answer if you start from the middle of the area. So our answer here is 8.8. Problem number 9. Final exam scores in a mathematics course are normally distributed with a mean of 71 and a standard deviation of 6. So we have x normal with 71 mu and 6 the standard deviation. Based on the above information and z-table in the blanks, fill in the table below. So from exam score to z, let's make a formulation here. From exam score to z-score, and from z-score to percentile. From exam score to z-score, we're going to standardize by using x minus mu over sigma. And from z-score to percentile, just check the z-table or calculator, depending on the precision and what they want. Check z-table or use calculator. From percentile to z-score back, we're going to apply inverse phi operation. And similarly from z-score to exam score, we're going to apply phi inverse to the z-score, which is x minus mu over sigma. Here we're going to apply phi inverse to percentile. Let's begin. Our exam score is given at 66.98. From exam score to z-score, we're going to standardize. So our x in this case is 66.98 minus mu, our mu is known, which is 71, divided by sigma. So this value will give us our z-score. So our z-score will be negative 0.67. And if we would like to know the corresponding percentile of this z-score, you can either punch in your calculator and find the value or check the z-table. For the homework purpose, we're going to use the z-table here. So negative 0.67. We go to negative 0.6 here and 7 on the row. 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. So this is negative 0.67, which is 25.14%. The second row will be done using the same logic. So our z-score will be 53 minus mu divided by sigma, and that is equal to negative 3. So our z-score is here negative 3. And if we go to table, to negative 3 here, and negative 3, 0, 0. So which is, if you multiply this value by 100, it's going to be 0.135%. Now we have z-score, and they want to know the percentile and exam score. For percentile, we're going to check z-score table again. So this time it's going to be positive 3. And if you scroll down to positive 3 on the z table, that is 3.000. So it is 99.86. And if you round up, 87. 99.87%. From z-score to exam score, we're going to use inverse phi operation. So x minus mu over sigma, phi inverse of this value, given z-score 3. And phi inverse of this operation is x minus mu over sigma. And we know our mu and sigma, and we would like to know the corresponding x value. So x minus 71, which is our mu, over 6, which is our sigma, equals to 3. Here we can solve for x. Here x is equal to 6 times 3, which is 18, plus 71. So x is here equal to 89. The last row is the inverse operation of percentile. So if we take inverse operation of percent, we obtain z-score. So 97.72%, 97.72% written in decimal, 97.72 is equal to 1.999 z-score. So our z-score is 1.999. And corresponding exam score is, again, x minus mu over sigma equals to 1.999. And we know our sigma and mu, which is 71 and 6. So if we cross multiply, it's going to be x is equal to 1.999 times 6 plus 71. And that is going to be 83. Problem number 10. Consider a normal distribution curve where the middle 45% of the area under the curve lies above the interval 3,19. Use this information to find the mean mu and the standard deviation sigma of the distribution. Let's try to illustrate the situation. We have a bell curve from 3 to 19, and we were given that this area under this curve is 45%. Everything here is 45%. Now we can use the symmetry, and we know that this is the point where mu is, that divides the bell curve evenly. That's the midpoint of 3,19. So mu will be equal to 3 plus 19 divided by 2, which is 11. So now we know that our mu value is 11. Now we can use the symmetry and divide this area into 2, and we can take from 11 to 19. So probability that x is between 11 and 19 is the half of this area, which is half of 45%, which is 22.5%. Now we can standardize this 11 and 19. 11 is corresponding to 0. So where 11 is corresponding to 0 in standard normal distribution. And 19 is some z1 value, which is 19 minus mu over sigma. This is how we standardize, equals to 0.22.5. Now we can execute this value because we know mu. So that is going to be 8 over sigma. So this probability by definition means probability of 8 over sigma minus probability of 0. Probability of 8 over sigma minus probability of 0 equals to 0.225. We know that probability of 0 is 50% in standard normal distribution. So we can add 0.5 on both sides. So we can clean here. And if we add 0.5 on both sides, we have here probability 8 over sigma is equal to 0.725. Now we can take inverse operation, inverse phi of both sides. So left hand side goes out as 8 over sigma, and the right hand side will be phi inverse of 0.725, which is this value, 0.5977. Now we can solve for sigma. If we cross multiply and divide by 0.59, so sigma will be equal to 8 over 0.59776. And if you do that division, you're going to obtain 13.38, 32, 94, 822. So our standard deviation is 13.3832. Problem number 11. Healthy people have body temperatures that are normally distributed with a mean of 98.20 Fahrenheit and standard deviation of 0.62 Fahrenheit. So we have x being normal with the parameters 98.20, comma 0.62 squared. Again, here 98.20 is our mu and 0.62 is our standard deviation sigma. If a healthy person is randomly selected, what is the probability that he or she has a temperature above 99 Fahrenheit? So probability wise, that means probability that x is greater than or equal to 99, which is 1 minus probability that x is less than or equal to 99. So you can either standardize this, which is 99 minus the mu, which is 98.20 divided by sigma, and whatever value you find will be your z value, and z of that value can be checked either on z-score table or you can directly use the calculator. So here our z value will be 129,052, which is corresponding to 0.098469. So this is the percent. Or you can use one of those calculators. Let's use directly calculator. So we have 98.20 to 0.63. So 98.20 to 0.62, and we would like to know x is greater than 99. and as you can see here, it's the same probability, 0.098469. Now part B is asking, a hospital wants to select a minimum temperature for requiring further medical tests. What should that temperature be if we want only 2% of healthy people to exceed it? This time we're going to use inverse operation. So x minus the mu, which is 98.2, divided by sigma, and we want it equal to 2%, which is 0.02. So here we are going to take phi of 0.02 and phi of this probability and solve for x. So phi of this probability, phi inverse of this probability, is inside of the parentheses, which is x minus 98.2 over 0.62, and phi of 0.02 can be found using the inverse normal distribution calculator, which is negative 2.053. And x will be equal to 0.62 times negative 2.53 plus 98.2. And that will be equal to 99.47. Problem number 12. The length x of a fish from a particular mountain lake in Idaho is normally distributed with mu 7.7 inches and sigma 1.7 inches. So we have normal distribution with 7.7 mu and 1.7 standard deviation. Is x a discrete or continuous random variable? In our case, length of fish is here continuous random variable. B. Write the event a fish chosen has a length of over 5.7 inches in terms of x. So that means x is greater than 5.7. Find the probability of this event, means probability that x is greater than 5.7. That is 1 minus probability that x is less than 5.7. So we're going to standardize this x value. So 5.7 minus mu, which is 7.7, over 1.7 will be equal to negative 1.1764. And if you round this up to negative 1.18, because that is closer to negative 1.18 side, and you're going to check this on the z-score table. Let's do it together. So we go to negative 1.1. So negative 1.1 and 1/8. So which is the one just before the last one. So 0.119. So this probability is 0.119. So 1 minus this probability is the answer. Find the probability that the length of a chosen fish was greater than 10.7 inches. So that means probability that x is greater than 10.7 inches, which is 1 minus probability that x is less than 10.7 inches. We're going to standardize this x value, 10.7 minus mu, which is 7.7, divided by sigma, which is 1.7. And we're going to obtain here 2.9411 z-score. And if we check 2.94 z-score on the table, we see the probability that is corresponding to this z-score. 2.94. So first we go to 2.9. 2.9 is here, and 4 is 0, 1, 0, 1, 2, 3, 4. So coming from here and coming from here, it is 0.9983 and rounded up 0.9984. So 1 minus this probability is the answer. Part E is asking the probability that x is between 5.7 and 10.7. Probability that x is between 5.7 and 10.7 means probability that x is less than 10.7 minus probability that x is less than 5.7. We already found those values from the z-score. Probability that x is less than 10.7 is this probability, 0.9984, and probability that x is less than 5.7 is this probability from the z-score. And this subtraction is the answer. So 0.9984 minus 0.1190 is the answer. Problem number 13. The score on an exam from a certain statistics class X is normally distributed with mu 74.8 and sigma 9.3. We have normal distribution with parameters 74.8, 9.3 squared. And it is assumed continuous variable. Write an event a score over 62.8 in terms of x means x is greater than 62.8. Find the probability of this event means probability that x is greater than 62.8 means 1 minus probability of x is less than 62.8. You can either standardize this by 62.8 minus mu 74.8 over sigma, and you obtain a z-score here, and 1 minus that corresponding z-score probability will be the answer. Or you can directly plug in your calculator. So let's find the z-score here. So our z-score here will be equal to -1.290. So you can check the z-score of -1.29. Z-score of -1.29 is, we go to -1.2, which is here, and 9 here, which is 0.0985. So 1 minus this probability will be the answer. So it's going to be 1 minus 0.0985. If it is not z-score sensitive homework, then you can directly use the calculator, entering the parameters mu and sigma. Find the probability that a randomly chosen score is greater than 86.3. So that means probability that x is greater than 86.3, which is 1 minus probability of x is less than 86.3. So we need to standardize this x value, which is 86.3 minus mu, which is 74.8 divided by sigma. And we obtain here 1.236. And if you round this z-score up, which is 1.24, and check it on the z-score table, 1.24. So we find 1.2 and the fourth decimal from here. So 0.8925. So 1 minus 0.8925 is the answer. Part D is asking the probability between 62.8 and 86.3. So probability that x is between 62.8 and 86.3 means probability that x is less than 86.3 minus probability that x is less than 62.8. We already found this and that. So instead of probability that x is less than 86.3, we're going to use 0.8925. We found it on the z-score table. And probability that x is less than 62.8 is 0.0985. And this subtraction will be the answer. Problem number 14. Scores on a certain intelligence test for children between ages 13 and 15 years are approximately normally distributed with mu 106 and sigma 18. Our random variable x is normally distributed with 106, 18 squared, mu and sigma. What proportion of children aged 13 to 15 years old have scores on this test above 96? And that means probability that x is greater than 96, which is 1 minus probability that x is less than 96. And we can either standardize this and check on the z-score table. Let's do that. 96 minus 106 divided by 18. We obtain the z-score as negative 0.555, and we can check the z-score of 0.56, negative 0.56, and that corresponding probability, negative 0.56, we go to negative 0.5 here, and the sixth. This is 0, 1, 2, 3, 4, 5, and the sixth column. So it is 0.2877. 0.2877. So 1 minus that probability is the answer. And if you wish to do it on calculator, you're going to go to calculator. We know the mu is 106. We know the standard deviation 18, and we would like to know that is greater than 96. So it is 0.7107. You can see from the calculator here. Part B, enter the score which marks the lowest 30% of the distribution. So that means the standardized x minus mu over sigma is equal to 30%. Here we have x minus mu is 106 and sigma is 18 equals to 0.30. Here if we take phi inverse of the both sides, we obtain x minus 106 over 18 equals to phi inverse of 0.30, and phi inverse of 0.30 is equal to negative 0.5244. So negative 0.5244. And we can solve for x here. So x will be equal to 18 times negative 0.5244 plus 106. So that x value will be equal to 96.56. Part D, enter the score which marks the highest 5% of the distribution. So here we're going to set up the similar, like x minus 106 over 18, but this time we're going to take phi inverse of 95%, because highest 5% means lowest 95%, which is 0.95. So if we take phi inverse of both sides, we obtain x minus 106 over 18 on the left hand side, And on the right hand side, we need to take phi inverse of 95%, which is 1.6448. So 1.6448. And if we solve for x in this equation, x will be equal to 18 times 1.6448 plus 106. So we obtain x as 135.607. That's it for normal distribution packet. Thank you for watching.